people log in. People log in. We'll see what happens.
Whatever. Calibrating this thing is going to be amazing.
What's that?
Calibrating the thing is going to be amazing.
Oh yeah.
Oh wait.
What is that for?
Hmm?
I haven't used that one.
You haven't used this? This is like a diffraction.
Yeah. I mean, I guess I figured, but
Yeah,
what is it for looking at?
It's just like you point at some source that's pretty bright,
Oh.
so a star or something, and you use it to calibrate like the image. So it's like it has to show like there's a peak and there's a diffraction peak, and you just put it in the center. It's calibrated.
Oh, okay.
That's as much as I know.
Wow, so good.
Oh yeah, you can definitely see something.
I can still smell the smoke.
Oh, we can track that. Yeah.
But
That's
okay. I don't think there's going to be anything Oh well, at least I know how it works now. I'll sign up for more nights. Just yeah. So the problem in Oregon is like I don't know what it's like in Puerto Rico, but in Oregon, if it's not summer, you don't see the sky like hardly ever.
right.
So I don't know what the fall or winter skies look like. Like I'm not familiar with them.
Oh, yeah, okay.
So
Honestly, I'm not familiar with anything observation related. But usually back home, it's basically wherever you are. It's dependent because like if you happen to live near a place where it's mostly rainy, then you're probably not going to see a lot.
yeah.
Just because of the cloud coverage.
Do you get like a lot of little island microclimates like Hawaii?
Oh yeah.
Oh, cool.
Yeah, it's very similar. Like where school is, like it'll rain every day, like 3 p.m. That's the thing, and then like 5 towns south, you have a basically like a desert climate.
How are things going after all the damage?
We've improved a lot. In a social sense, our government, governments are governments.
All of the government is a total disaster right
Yeah.
now.
So like one thing that is still very much the same since like the first like attempts to fix it is the power grid system.
Mm-hmm.
Like it hasn't improved a lot. Yeah, so like that's something people are not very happy about. Just like, yay.
Oh, it was Seth. I was like,
Yeah.
oh god, it's a person.
Yeah. So it's like that's something that just like I remember like whenever like we have strong rain,
Mm-hmm.
we lose power.
Oh god.
And it's it's a tropical island. You have strong rain like almost every day.
Yeah.
So it's like we will have power outages like every day. But other than that, it's like it's been very good. And again, like in a communal sense, it's improved a lot because people, I don't know, have changed the perspective a little in terms of like, well, if the government's not gonna make things work, then sometimes we can help think like small things help work. So there's been that.
Yeah, I just worry there's going to be more and more storms like that.
Yeah, no, it's crazy to think like it's, these things are not expected to get better. Like I was talking to someone about like the California fires, and it's like, well, it's like this year, and like the expectations kind of like, get worse and worse, like over the next 30 years. So it's like, wow.
Yeah, it's been pretty hard to be hopeful lately.
Yeah. So get finger like maybe it's one motivation to like, study science. So it's like you hope to like I guess like figure out some stuff that could potentially. I mean, in terms of climate science, it's hard because like people have known
Yeah.
that like stuff is going bad and you should change it for like on like over like more than like 60 years. It's like we don't care about that.
Yeah, that's kind of where I'm at. Like, even just 5 years ago, I was like, oh, I'm going to do this, but maybe eventually I'll move into climate science. Um,
And now I'm like, nobody needs climate science. We have the science. We need social solutions.
Yeah, it's amazing like to see like I have a few friends in the atmospheric science like community.
Yeah.
It's amazing to see like how much people are like really just getting into it for the policy aspect, like from the science perspective, but they want to do policy.
That's actually a really good point.
Yeah, I find it amazing in that sense. And like I've also seen like in terms of space, like I know for space weather, like there's been an improvement as well, like about like space policy.
Well, for some reason, even like the craziest, like extreme people in the government seem to care about space weather and
It's
like listen to it.
Yes, and honestly, I think it's because of the people it affects. Because
Yeah.
climate change, like the initial people that I expect it to like affect, it's not really the wealthy. So like I think from that perspective as well, like I have a friend that's really into like policy. And she was saying like I never realized that like climate change affects people by race differently. And I
Yeah.
was like, it's kind of a not a great thing, but yeah, it's kind of like why people don't really care that much about climate change. In terms of space weather, it's just like everyone's going to be affected. So
Yeah. Well, I guess it can also, like, a severe space weather event could knock out a much larger power grid
exactly.
at any point in the
Yeah.
world. So.
I've seen some estimates of like, I think the reference they use a lot is the Carrington event. It's like if one of those happen, it's like basically.
What's the Carrington event again?
Yeah,
I mean, I am familiar with
name,
it, but I don't remember what it is.
Yeah, I think it was like in the late 18th century or 19th century. I always mess up the dates, but like 1860 or something. Basically, it was a very strong geomagnetic storm that happened.
Okay.
And it's one of the ones that it's referenced a lot, just because like they had telegraphs at that point.
Yeah.
So like yeah, people noticed that the telegraphs were acting all funky. Basically, they got a lot of short circuits, and then it was just a very strong geomagnetic storm. Like there's this very impressive painting by a Cuban artist of the auroras in the Caribbean. And so I usually just think of that. It's just like imagine seeing an aurora in the Caribbean. It's like it's a strong storm.
This was precipitated by what, a coronal mass ejection?
Yeah, it was a coronal mass ejection.
My solar knowledge, like every so often I end up in some sort of like solar boot camp, but I just never absorb it.
Yeah, it's a lot of jargon. I'll be honest. Like there's a lot of jargon.
No, it's not like that. I don't come back to it regularly enough to remember it very well.
Yeah.
But there's supposedly is it a solar or something? Some sort of solar summer school that we do here every year.
Yeah.
Did you do it?
I haven't done it. I wanted to do it this year.
Yeah.
Yeah.
My friend did it this year, but it all ended up being online. So.
Well, yeah. Yeah, I ended up not applying because I was like, well, the world's going to an end, and I wasn't really in the mental state to apply to more stuff, and I was like, oh.
No, good for you.
Yeah. But yeah, I've been kind of like I've been at some meetings of that because I worked at NCAR for some summers. So like I've seen it. I've gone to a few like meetings and stuff.
Cool. I was just like trying to see if there are people without being in the chat. I don't know. I don't know how it works.
It says we have 5 concurrent viewers.
Hello, viewers.
So I think we can try to start.
Well, yeah, there's not much to look at, unfortunately. Folks who are here with us. But if it does clear up, we will definitely point at something.
Yes. So.
But thanks for joining us anyway.
Yep. Hopefully it'll clear up. Maybe we'll get to see at least some planets. Hopefully. I'm gonna grab it.
Yeah. Sorry. Here.
Oh. I'm gonna get the red one.
Or you take that. Yeah, I just was like, oh, we're just chatting. We should probably see if people are actually on this stream, but
yeah,
I don't know. Yeah. Okay.
It's 5 concurrent viewers. It can mean that people got in, got out, but.
Oh, so they're not necessarily currently in
No,
the stream.
I don't think. Maybe that's cold current, maybe.
Oh, it just dropped off.
Okay, so yeah, maybe.
Okay,
some-
nice.
we-
We have
we
like
said
2 people.
Our conversation about climate was more interesting. I guess.
Yeah. Well, I mean, we can continue talking about that. There's nothing to look at.
Oh, there's one little object popping up way up there.
Where?
I don't know what that is.
Well, I don't see it. If you see it, you should point at it.
Like I can see it with my eyes, but
Yeah, so for anyone actually listening, the trouble with our setup here is that we don't really have a way to steer the telescopes by hand to any random thing that might pop out of the clouds. Everything is done through basically this computer program where we have a map of the sky and we pick our object and we click on it and we just say telescope, go to the object, and then it just does it automatically. I don't know if there's a way to get the map on
yeah, I think
the screen.
if we share a screen, I think that might.
Yeah, we can try this.
Okay, so it's
Share the Sky X,
yeah.
yeah.
share.
Yeah.
And hopefully you get to see this.
Yeah, so there's our zoom, and then they should be looking at this if they're watching. But yeah, this is how we drive the telescope. Nice, there we go. And usually it's very effective when there's multiple things to look at, but tonight we're not getting much because of all the smoke in the air and the just general atmospheric turbulence. So it's pretty cool though. We can just sort of pan around here and zoom in, zoom out. This yellow or orange line here is showing the limits of what the telescope can look at. And I think the green line is the actual horizon if you didn't have the lovely flat irons to deal with in the mountains, you would be able to see to the green line. The telescope can only do some of that, mostly because we're sitting here in a roofless building, and there's of course the building blocking part of it, and then the mountains too. But we get a pretty good slice of the sky usually. And if it wasn't so cloudy, we'd probably be looking at some stuff here in the Milky Way, which is running roughly north-south across the sky. And there's a lot of stuff going on in here because this is close to the direction of the galactic center. And then this blue line here, I believe, is the ecliptic. So if you look along that line, you will see all of the various constellations that go with the zodiacal signs. So we got Capricorn, Aquarius, Pisces, and so on and so forth. Sagittarius is in there too.
Yeah. I think you can actually zoom in to an object as much as to actually show it on screen.
Yeah, the software is pretty cool actually.
Yeah, I think I'm gonna do this. Zoom.
Oh, cool.
Probably maximum.
Wait, is the zoom gonna do the software or the telescope?
Oh, that's a good question. Okay, so if we go here,
Then you can slew.
yeah, I know you can slew, but that'll change. Right now we're basically putting our telescope to look at Saturn, but I want to actually look at it through the app. Maybe I'll do it by hand.
That's what I usually do. And this is actually not the only app that can zoom in this far and look at things. You can actually do this with quite a few different apps or programs on your computer. I usually use Stellarium, which is free and available for every operating system out there. So Windows, Mac, even Linux, you can use it. That's pretty nice. There's also a variety of basically video games that you can get on Steam that are like universe simulators, and you can just look at objects and get all the data and crash planets into each other and explode stars, which is pretty fun.
I've never heard of that.
Oh, wow.
This might be something I do as soon as we got out of here. Like, I might actually go crazy downloading stuff like this.
The one I'm thinking of is called Universe Sandbox, I think. It might be a little old by now, but there may be a new version. So, and if not, there's probably a successor.
I mean, I don't mind playing with something with maybe like older graphics.
Yeah.
I mean,
Well, I think the last time I tried to boot it, there was some issue, but yeah,
Okay.
I don't quite remember. It's been a while since I looked at it.
probably better if it's old. I don't have such a strong computer, so
Yeah.
like,
There's actually another good one. Let me see if I can just Google the name really quick
Yeah.
without damaging anything. What was it called? It was it's in Space Engine. That's what it's called. Maybe that's the one that's no longer
Space Engine?
maintained. Yeah, Space Engine, the Universe Simulator. This one, I don't think you can explode stars. I think you can
Oh,
just sort of
man.
browse around and look at stuff.
not exploding stars.
Yeah, it's pretty cool though.
Yeah.
I'm not sharing it with our
No.
4 viewers, but maybe I could do that in a minute.
Yeah, if you just share the screen you're sharing, in Zoom, I think they can actually see this.
New share. Okay, instead of the Sky X, we're going to share this guy. Yeah,
Kind of interesting.
Space
Today,
Engine.
we were learning of one of our professors here in the APS department. He has a flight simulator of a black hole, and I think in class we were talking about like all his videos that he has of like free falling into black holes, and that was my plan for tonight.
Oh, is
Just
this Andrew
watching-
Hamilton?
Yeah, watching
He has,
watching myself.
yeah,
Yeah, this is
he gives
Andrew
really
Hamilton.
interesting talks about black holes.
Yes. So
Okay,
with
so this is not
this-
so useful, I apologize. But this is a cool thing. You can download it to your computer and play around and look at cool stuff like nebulae and spiral galaxies and planets. And it's a nice way to get lost in the universe.
I don't know a lot, but I think isn't that Vega all the way up there?
I'm going to stop this share real quick so I can go back to the streaming thing and monitor it.
Okay.
Vega? What?
Yeah, the thing over like on top, really on top.
Oh, there, the fake thing.
Yeah.
It
It's
might be. It doesn't
Looks like the right color, but there's a lot of smoke in the air, so
Yeah.
it's entirely possible. Let's.
Oh, also I think Jupiter is showing up, or Saturn.
Well, so what do we do with this here? How do we show the viewers the actual object in the telescope? Because I
So,
haven't done this before.
Yes. So in order to show the actual object, we actually have to take a picture. And to take a picture, are we sharing our screen right now?
No, we're not, but we can reshare it. Sorry.
Okay, no worries. I just want to make sure that everyone gets to see this.
Oh, yeah.
So,
Okay.
so we were here just on the telescope monitor, and we use this Globular telescope to look at Saturn. But if we actually want to see the picture from the telescope, we would take a photo over here. But before taking that photo, we actually have to make sure we have the right exposure. Exposure just means how much time you're absorbing light from that object. Usually, we go a little lower than this. So usually, I don't know.
Maybe 0.1 or 0.01.
Yeah, something like that. This is just a rough estimate to start.
That might be a little low, actually. Do it 0.1.
Of course.
Just since we're getting a lot of whoa sirens going on here.
Yeah.
A lot of distortion from the smoke.
And also, as soon as we take a picture, we haven't changed the filter that we're taking in it, but still, it'll work.
This is a great picture.
Yes. So, okay. So
Now I do new share.
now I think if I do this,
Oh, did you do the whole monitor though, or just the Sky X?
we'll see now. Is it?
Oh yeah, we have to wait a couple seconds for it to come up on the live stream. There's some sort of delay.
Probably not.
I think it's just. Oh no, it is there.
It is
Okay,
showing.
so there's our really wonderful, amazing picture, which is mostly comprised of just a bunch of noise. So we usually can deal with this by changing the exposure setting or some other setting on the camera, but we might have a hard time tonight. But we'll mess around with it a little bit. Saturn might also have just gotten obscured again. I'm not seeing it by eye.
Yeah. Actually.
You probably
Yeah,
can't hear me when I talk that direction.
Yeah. Maybe try to see if that thing over there is Vega. I don't know.
We can certainly try, although let's see. I don't see it anymore.
It's still very faint. Like it's the only thing I can see in the sky. I'm not sure if it is Vega. I don't know what it is. I know it's like super up there. Also, since I like stars, I'll always want
There's
to
a
look at a
message
star.
in the, we have a message in the chat. Sorry.
Oh, see there.
Here, move our little thing. Move our video. Annalise says, I feel like I'm in an astronomical interactive video game. I love it. This message is held for review.
Sure.
Oh,
Well,
it's just a Saturn. I don't know why I did that.
I don't know. But yeah, we were actually showing a video game.
Yes, that we did show a little thing on the web of a game that I have played in. Well, it's not really a game; it's a simulator. But there are video games that kind of function like simulators where you can crash things into each other and experiment with like what would happen if you put Earth around a black hole, or what would happen if you move Jupiter into where Mercury is, and that sort of thing. But in the meantime, we will enjoy entertaining you with our silly live action video game.
Trying to find something within the dust. Yeah, and if we can actually see this, it might be good for calibration purposes.
So Annalise is asking about asteroids. Maybe, I don't know if you're asking if we could look at asteroids. And unfortunately, with these telescopes, we cannot. Asteroids are just far too dim to really be seen with the equipment that we have here on deck and in our level of light pollution here in the greater Denver Boulder area. Oh, okay, there you go.
Got to see something.
So we've got, what do we have on here? Saturn or Vega?
It's Vega.
Vega is actually coming through the haze. That's pretty cool. Oh, where'd it go?
God.
What just happened?
I zoomed out too much.
Where did it go? It's somewhere there.
Is it just covered right now?
Oh, it's not a picture. It's taking a live feed actually.
Yeah.
So yeah, if you're seeing this with us, you might see this noise sort of shifting around like like an old TV. And it looks like the camera is actually taking a live feed of the sky. So all that shifting that you're seeing is actually just the atmospheric turbulence with all the smoke that we have. But even when it's not smoky, this happens anyway, because of course the air has stuff in it, right? It's oxygen, it's nitrogen, stuff is moving around, wind is happening. And here in Boulder at the base of the Flatirons and the foothills, we get quite a lot of turbulence in town. So the seeing is not always as good as you would expect for being as high up as we are.
Okay, so these are some preset, like, just changes the contrast in the image a little bit. I think now we can pull it out a little bit.
Oh, there we go. Okay, very good.
But can I change the field of view though? Because
I am honestly not sure. I've actually never really interacted with the camera very much. I've only ever come on like pretty nice nights before the pandemic when we could have visitors here on the deck, and we didn't use the camera very much. Yeah, so these may not be the individual particles, of course, on the video, since I don't think the camera is that efficient at looking at such small things, but it is showing sort of the overall like light noise of the sky above us, and how that changes and shifts around. Okay, there we go. We got Vega on the view. Hoping it will stay this time. So
I'm gonna go slow because every time I go fast, I lose it.
Oh yeah. Oh yeah. See, it just got covered up by the general atmospheric turbulence. So if you just wait, does it come back, or was that because you zoomed in?
I think it's. I don't think it was because I zoomed in. I think it's just like the atmospheric turbulence is just missing out the picture.
Yeah, I would say so. I'm kind of impressed it's coming through actually, because I think the planets. Yeah, there comes again. The planets should be brighter than Vega to the eye, just because they're closer to us than another star. But Vega is one of the brightest stars in the night sky that you can see. It is usually quite close to overhead in the summer. I am not actually super familiar with the autumn or winter sky because I'm from a very cloudy place where we don't get to see a lot of the sky in winter. But I think it's still pretty visible for most of the year. Normally on a nicer night, it will appear as a very bright white blue star in the sky. I think it's a blue giant or blue supergiant or something like that. But honestly, I'm a planetary scientist. It's been a long time since I had to think about what type of star is. But it is blue. I promise you the color is correct.
Let's see if I could take a picture, still picture that just shows it, so we can actually. It's not going live or anything. Oh, that's it.
That's a little too much exposure, I think.
Yep.
Yeah, so here Marcel has set the exposure time to 5 seconds,
5 seconds.
which normally on a good night, if you're trying to photograph a very dim object in the sky, that would be a useful exposure because these objects are very dim, they're very far away. So in order to see them clearly, you want to collect quite a lot of light with your camera and your telescope. But tonight we're just getting a lot of light bouncing off of the smoke and the atmosphere turbulence. So
Oh, there it is.
doing it for too long of an exposure just saturates the camera and you just get a white screen. But this is a much nicer one.
Yep.
Yeah. So maybe not quite the picture you were hoping for, but this is sort of the best we can do at this time. But this is actually what a lot of astronomers will see when they're doing their research or, taking images of either stars or deep sky objects like galaxies. You'll get some sort of a bright source like this that you're interested in photographing. And then, like I was describing earlier, this general speckled mess everywhere is going to be just the background noise, what we call the sky brightness. So usually if you are an astronomer and you need to study some star or take an image of it, you need to remove that noise from your image so that you can just focus on what you're seeing in the star. So they have many ways to sort of calculate what that mean noise is and subtract it, so then you can just get an image of the star without all that sky brightness, sort of distracting you.
I think that answers Annalise's question as well. She was asking if those are particles.
Oh,
I think
yeah.
she means like all this random stuff that's going on around.
Yeah. At some point in my tirade, I went through and mentioned that.
Yeah. You just mentioned that. Yeah, it's just noise because of.
Yeah, and you'll get the sky brightness for, in a variety of situations. It's not just when you're sitting here on Earth looking up through the night sky. You can also get this from space-based telescopes looking at very far away objects like other galaxies. There's still going to be some sort of background brightness to even that dark space up there, just from other nearby stars or objects, and you'll do the same sort of process to get rid of that sky brightness noise so you can focus on your galaxy or whatever you want to look at. And then of course you can do all the sort of normal photo adjustments that Marcel's messing with here.
I'm just playing around here, trying to make this look as good as I can.
Well, it's fun. I literally never used YouTube Live before, so this is kind of a interesting experiment.
It is a very interesting thing to just like go here. Okay, so I'm shutting down.
Oh, there we go.
There you go. Nothing a little bit of photo editing can improve,
Yeah. Now I'm going to guess that probably these excess pixels here are just very hot pixels. They're probably not other stars, although I guess it's possible they could be. Hard to kind of tell from this very simple image.
Yep.
It seems to be getting brighter.
Yes, it does.
Do you want to try using that on
Yeah,
Vega?
I wanted to.
Okay.
So, I don't know, you can see this at all?
Light it up on your phone.
Yeah, or can you point that lamp over here?
Yeah, that's better.
Maybe.
There we go.
Okay, here. So what I'm holding right here is the diffraction grate, and what we're gonna do with this is we're gonna place this on the telescope. Maybe get it lowered down because it's kind of high right now, looking at Vega. It'll be hard for me to get.
Well, oh yeah, we'll lower it to put it on, but then we'll have to put it back up at Vega in order to do something with it.
Yep. So hopefully. Pretty.
Oh, do you want me to lower it?
Yeah, just get out of the window.
What do I just close my Fitz viewer here?
Yeah, you can just close
Okay.
that. I don't know, just put.
Okay,
this
let's
is some
just
random.
slew it at Saturn.
Yeah. Also, I think they're clearing up a little bit right now.
Yeah?
I mean,
Oh,
naked
I
eye,
see
you can see something.
Is that Saturn or is
I
that
think
Jupiter?
that's Jupiter. Maybe.
Well, I'll take a quick picture of Saturn and see if it's Saturn, and if not, we'll try Jupiter.
Yep. My intuition says it's one of the others.
That's kind of nice to have them right next to each other. Very convenient. Okay, if I go to the camera, that seems fine. I'll just take photo.
Yeah. Take photo.
Okay.
And right now it's just gonna take one still picture.
Yeah, it's not too helpful. Let's see, should I do it longer maybe? I don't know if that'll help. Let's do,
Maybe.
whoops. I don't think we're looking at Saturn because we're not seeing.
We're not seeing anything.
Yeah.
Try Jupiter.
Let's try Jupiter. Since there's so much turbulence and smoke, there's literally nothing else I can look at in the sky to orient myself to figure out where we are.
Oh yeah.
Okay, back to the camera. Let's take a photo.
It's probably not.
Oh yeah, there we go. That's exciting.
And we get to see moons.
Awesome.
I love
Yeah.
the
So
moons.
here we have. So we are actually looking at Jupiter right now. Oh, where is Sirius located? That is a good question. It's probably quite low in the sky right now. It may not be visible. You can't really see my hand. Low in the sky. It might not be visible because of the mountains, but I'm trying to remember my constellations.
You can always pull it up.
Yeah, I can, but I just should remember. Well,
I don't
so
remember.
Sirius is the dog star, right? So it's part of this like dog constellation, and the dog is always following Orion, the hunter.
Yeah.
But Orion is a winter constellation here in the northern hemisphere, and so it's not up right now. I think it comes up much later in the evening. It certainly does in summer. It comes up 2 or 3 a.m. or something. So now in autumn, it might come up closer to midnight if I had to estimate. So we probably can't see that right now. I will check my work, I guess, by looking at, what is this? I don't want the magnifier. Where is the Sky X? Oh, this is the Sky X. Oh, I see what happened. Okay. Yeah, so let's see if we can take a look here to figure out where it is. It should be this way.
Where's these? No.
As I said earlier, I'm a planetary scientist, so I'm really bad. Yeah, here we go. Here's Orion.
Okay.
So as
The hunter.
the sky turns, it's gonna like, so Orion's eventually gonna march over the horizon here, the green line, and into the view of the telescope. But yeah, so Sirius, the doggy, is here
Way out of our field. of view.
chasing Orion, and Orion is the hunter. He's got his bow here. And then Taurus is sort of running at Orion. That's kind of how I remember where these three are with relation to one another. And it looks like they're sort of just below the ecliptic, this blue line. So that is out of view right now, but we do have Jupiter, a favorite planet of many. I'll move this back so you can see the picture again.
Gotta love Jupiter, you know.
Yeah. So Jupiter here is pretty bright since it's large and relatively close compared to stars. But this is actually pretty fortunate. We get a really nice shot here of the 4 Galilean moons, the 4 largest moons of Jupiter. Let's see if I can name them all. We've got, and I don't know what order they're in, I apologize, but I know their names, and they are Io, Ganymede, Callisto, and Europa, right?
Yep.
Yes, okay.
Yep.
And I wish I could tell you which one is which. I believe the closest one is Io.
You know the good thing is?
Yeah.
We have the app.
I know, yeah, but wait, does it do the moons?
Yes, it does the moon.
Okay, great.
Yeah, so
Yeah, I just remember that Io is probably the closest one. You can check my work, because Io is this very volcanically active world. Like, you would not want to be on the surface of this moon. Like, it's a disaster.
that's good for geologists. You know?
Yes,
There's
very
a lot
interesting.
going on.
Geologically.
Oh, there you go.
Okay, so right now, it of course depends on where they are in their orbit. So right now, Europa is this one that looks quite close to Jupiter. Io is the second one to the left. Ganymede is further out on the left, and this one all the way out on the right should be Callisto. Yeah.
Yep, looking at there.
Let's see. Annalise asked, what app would you recommend for a star map? I can also research it. So, do you have an iPhone or an Android?
I have an Android.
I do too. Okay, we both have Android. So if you have Android or even if you have iOS, I think Stellarium will work on both operating systems for phones. Let's see, Android, yeah, Stellarium
Great.
is my favorite one. It's more designed for you being used on the computer, so it can be a little awkward. You can also use just like Google Sky. That one's pretty easy to access and pretty well designed. And you can, of course, use a feature where you just, my phone is right here, I can actually, like, you point it around and it will use GPS to like figure out where you're looking and show you what's in the sky at that present location.
I was looking at Stellarium, and I think even like on the phone you can use the web-based like version. So like that's what I was using earlier, like the sky. But I think the app on Google Play has a price. Maybe it's like a pro version. I haven't researched on this a lot. Obviously, like if you get the pro version, it's probably a lot more fancy.
Yeah, there should be a free version for Stellarium because it is an open source app that was originally designed for Linux, which is always a free operating system. So that's probably how they started. And there may be a paid version with more features that I'm not aware of. Danielle is emailing us and telling us to use the camera mic, but I don't. If you're watching, Danielle, I'm not sure what to tell you. I thought we were using the camera mic, so I apologize if the sound is terrible. We are new to this process.
So I think one thing we can do here on Jupiter is just change the filter that we're looking. Like right now we're taking the picture in. So here in the app, you have this filter wheel. And right now we're looking at this R, and we have a table here with the actual like wavelength. It's 124 to 620 nanometers.
Oh yeah, I can see it.
Yeah. So it should be a good, actually. Yeah, that should be a good filter to look at.
124 at 620 nanometers. I don't know what that first number is, but the 624 nanometers is going to be close to the red end of the spectrum.
Yeah, I don't
Yeah, again, planetary scientists, all my data comes from like orbiters, so I never use filters. So tragically, I'm like the worst person to talk to about that. I passed my exams and now I don't ever have to think about it again.
Sounds great, says.
Yeah, I think we're okay on the audio.
Great.
Maybe that email was old, who knows?
Yeah, probably so. It's probably when we were like all the way over there talking.
Yeah.
So I did I hit take picture?
So the filter is gonna be like a band pass at 620 or whatever it was, right?
Yeah.
Okay, yeah, that makes sense. So that's meaning roughly that if you have a filter that allows in light of a certain color, that's usually what we call a band pass. I believe you can correct me if I'm wrong, but that's what I remember from my observations class.
I haven't taken it, so that's what I can imagine it means.
Yeah, I think that's right.
Oh, am I not taking the picture? What am I doing?
I'm not sure.
Ready. Oh, it's probably because I probably hit that
It's
thing.
I think if you click on the X. Oh wait, what?
I didn't click on it yet. Okay, so yeah, here it is.
Okay, here we go.
I just put H alpha, so right now H alpha is horrible.
So we're not seeing any H alpha.
Yeah.
Bummer.
Makes sense though. I just wanted to show like different filters on what they could see.
Oh, you can just select it like that. Wow.
Yeah, it's very
fancy.
It's very easy. These are
Okay,
the easy filters.
Okay, so click R. Do the red one again.
Yeah.
R is for red. I'm not sure if R is actually for red, but it's an easy way to
remember. I think it's the closest thing.
Yeah.
You can think about it. It's
okay. So do we see Jupiter in R?
We weren't seeing Jupiter in R. Did I change something?
Maybe
it's just the sky.
Yeah.
Maybe it's just covered right now. We might have just been lucky.
Okay. Well, what happens if we do the U filter? U is ultra or blue, right?
Yeah. U is blue, I think, towards ultraviolet, because I think G is for blue.
U is 358. Yeah. So that is the near ultraviolet.
Yeah.
Just a little bit higher than blue purple.
Yeah.
Okay, so one of our viewers is Seth, which means we have at most 3 non-faculty viewers.
We're all trying here. Okay, so take picture. See what we see. Oh, selecting its filter. Oh, okay.
Oh, interesting. So fuss with the levels and see what we can.
Okay.
I really got to learn how to use the camera software
Do
someday.
you want to try?
Well,
it's
I mean,
like
what am I looking at here? We've got.
Low contrast, medium contrast, high contrast.
Okay, so high contrast is terrible. Medium, low. Okay, and low just washes out the moons. I feel like there's a big difference between these two.
Oh yeah.
So
It's all relative, low contrast. So one thing you can do is actually just change there.
wait, so this should. There we go. That's right.
So just
I moved the black level up.
yeah.
So we've lost whatever that one was.
I
This one
think
was Io, this one was
Europa, I
Europa. So
think.
Europa has gotten washed out in Jupiter's sort of halo or whatever. Can we do this? Wait, what if we do low contrast and then we do this? Or am I doing it wrong?
I think you're doing it right. You can see that this is
Yeah,
getting brighter and brighter.
they're coming in. It's kind of nice looking.
Yeah.
Oh look, it's like a black body. That's pretty good. There we go. Oh, that's kind of nice. Oh, you can see some features even.
Oh, yeah.
Oh, that's fun. So Europa has some ice on it, as I recall,
You can actually
and
zoom
possibly a subsurface ocean on Europa. Although it's not maybe the most famous moon that you've heard about with an ocean under the surface. That might be Enceladus, which is a moon of Saturn. That's the one with jets of water going up into space. But Europa should also have a subsurface ocean. I'm not sure about Ganymede or Callisto and oceans. I don't recall those specifically. I don't actually know much about those moons myself. But yeah, mostly it's easy to remember Io just because it's a very volcanically active moon.
Yeah.
The horrorscape of sulfur and noxious gases. Yeah, well, at least we can see Jupiter. I am pleased with that.
That's one thing. Yeah, I don't think there's probably going to be anything.
What is this? What is this information this is giving us?
So
this is the max pixel value.
yes.
These are just must be the straight up pixel saturation values. Okay.
Yeah. This is giving you the distribution.
That's kind of cool that the distribution looks kind of like a black body.
Yeah.
I don't think it's specifically a black body because I can't tell what the axes are, but it happens to
No.
look like one in this representation. So for anyone watching who doesn't know a black body, it's just sort of a way that we describe the amount of light you're getting for a given color of light or a wavelength, and it tends to look something like this. And it's usually applicable to bodies which are like effective radiators, basically. So anything warm. So you'll see this for like a glowing element on a stove, or even like, a big supergiant star. They'll have the same sort of distribution of amount of light that you're getting at each color. But it'll, of course, change in value based on the temperature of the object. But again, this is probably not a black body because this is just the pixel values. Thanks, Annalise, for joining us. Yeah, I hope next week will be a little clearer. I'm probably going to sign up again for another go this semester because this is kind of a bummer.
Make sure to keep posted on the Planetarium site. I think that's where they're posting these.
Are they on FISC? They might also be on the SBO site. I'm not sure.
Yeah,
But
I think
either
they're
one, yeah.
streaming through both of them. So
That makes
either
sense.
way, just make sure to subscribe to this YouTube channel. You get
Dude,
your notification.
Can people subscribe to this YouTube channel? Like, I have no
think
idea.
so.
Okay,
I
well,
think
you guys
so.
can certainly try.
If
and-
not, just
Yeah.
I think the next one is like 2 weeks from now or something.
Yeah, we're doing a slightly
Almost
different
like-
cadence, right?
Yeah, it's weird. It's not bi-weekly. That's
Yeah.
what.
But the good news is maybe as it gets cooler and perhaps snows again, maybe these fires will calm down and we'll get some clearer air as we move into the winter. Because the winter air is usually quite a bit clearer than the summer air just because it's colder. So there's less motion going on up there. But of course, that's not always true. Since we are close to these foothills, we can get turbulence and, obviously if it's snowing, it's not going to be clear. But on a standard day without any inclement weather, sometimes the winter sky is like so much clearer that when you look up in the stars, you say, oh my God, they're so bright and beautiful. That's why.
Well, thank you,
Thanks.
Elise, for
Yeah.
joining us and spending some time here trying to look at the sky.
Trying. Yeah. Well, I'm pretty pleased with this Jupiter image. I want to save it.
I think you can.
Yeah.
Safe. Where it's safe, I don't know. We can look for it later. I wanted to see if we can actually get some. I mean, it's not great quality, but to see if we can actually get even the slightest feature of like Jupiter's like atmosphere.
Yeah, that could be cool.
Yeah. So let's try changing the exposure to see if anything is if we can do something here. So I would imagine going with a
Well, do it shorter, right?
yeah.
Since it's so bright, it's almost saturating.
Right. So what do we want to do? Like, do we want to go to the decimals or?
Why don't you try your 0.01 that we never ended up trying?
I keep forgetting this thing.
There you go.
And what filter are we in?
We were in the blue, interestingly.
Interesting,
So that was Jupiter in the ultraviolet, basically.
Yeah, which is
That's fun.
I would
Yeah. So this
imagine.
is we have two viewers and one of them is Seth. So all right. So to the remaining other viewer, I'd have no idea who you are or if you're one of our colleagues, but perhaps you are not one of our colleagues. And I will then assume that and say, so these different filters, you can see very different things with the object that you're observing in each one. It's kind of like looking through different colored glasses. So you can see very different features in like the ultraviolet or the infrared or even just the visual, which is how our eyes see. So that was kind of cool that we got to see some features in the ultraviolet on the moons. So yeah, I'm not sure what would be a good choice to look at Jupiter's atmosphere in.
I think red, but I tried the infrared just because like I'm trying different stuff. I don't know.
Yeah.
Let's go.
Eye is what again? What does eye say?
I think eyes in it's almost infrared.
Yeah, it's IR. Okay. Every time I do that, I'm looking at this like chart we have on the desk.
Yeah.
Yeah. So that's the near IR.
Because I think this is the first filter that we use, and the Jupiter look kind of nice here. I keep forgetting it's not connect. I want to actually take a picture. Move now.
Move now. Oh yeah. Okay.
It doesn't matter. As soon as you hit take picture, it'll
Yeah.
actually move.
Where'd it go?
And now I want to see what I got. Maybe the exposure itself is the problem. We're not seeing anything.
Well, we
but-
did go down by a factor of 10. We might just have to split the difference or something.
Yeah, I think what you were doing earlier, which is going to like 5 here.
Yeah, it was at a half second, but that, yeah. Oh yeah.
Like, or maybe even closer.
We
So
could do like 8 or something. 0.08.
Yeah.
Yeah. Let's see what that does.
if to see if like it's not again with the connect. Let's go back to basics. Oh no.
Wait, it's kind of scrolled over. Are we not just too zoomed in? Oh no. Okay, we're good.
Yeah. I think we have to go back to where we were earlier. Hopefully we get to see it again.
Yeah. Looks like some stars up there, but we've
Yeah.
lost Jupiter somehow. Are we on it in the
Let's see.
map?
Yeah, we are. It's interesting that we get to see it in the almost ultraviolet, which makes me want to
Wait, so what are we on right now?
I think we went to red, so
I wonder if the red is having a problem because of the smoke in the atmosphere. Like, I don't know what
yeah.
what light that would necessarily scatter. You would think it would scatter blue more effectively still, but
Yes.
um,
Either way.
okay, so what's G? Is this green?
I think it's G is for. It might be green, it might be blue.
What's the
That's
number?
475.
That's getting close
So
to
it's-
green, but it's not quite green.
it's
It's
like
like
bluish.
it's like a beautiful like teal, blue, green something. No dice.
We go back.
Okay, try the ultraviolet again. Maybe
Yeah.
maybe that's just.
Just because.
Well, that makes sense because UV is able to come into the atmosphere without worrying too much about like
Yeah.
minor atmospheric particles or fog or clouds. Like even on a cloudy day, you can still get some UV coming into the atmosphere. I'm not sure if it's the same wavelength as what this filter is covering, but it makes some amount of sense to me. I think we've lost it.
I think we just lost it. Yeah.
Okay, Jupiter's out. It's like, bye.
The good thing we
I'll
got
take a
this
look
is-
with the eye and see what I can see.
Yeah.
Oh, whoa, look at the moon. Oh, pointed at the moon. That's pretty cool.
Oh, yes.
Oh, guys. All right. Our two viewers. The moon looks pretty sick, so we're going to point at the moon if we can.
Blood red moon. Come on.
Yeah.
Yeah.
As long as it's not out of range.
I hope it's not going the right direction. Where am I?
That's east. So you want to go that way.
No sense of direction whatsoever.
You might have to zoom out quite a bit more.
M30.
There you go. And the Helix Nebula is up, but definitely not going to be visible.
It's up, all right.
Dear Moon, where are you?
I think there's a find thing.
Yeah, I usually just type it in. Moon. Okay, see where it is. Don't slew yet, because if it's out of, yeah.
Where is it?
Oh, there it is. It's next to Mars.
Oh, I see.
It's out of range of the telescope. Gosh darn it! But if we wait like half an hour, it'll be potentially in range. We dropped to one viewer though. It's just Seth probably.
Or maybe not. I would have said goodbye.
I don't know. Well, thank you, one viewer, whoever you are, for sticking with us.
Let me just type in random stuff. One can dream.
Yeah, that's not gonna happen tonight.
One can dream.
We're back up to 2.
Hey, look at that.
I mean, I could take a picture of it with my phone and then hold my phone up to the camera, and that would be funny.
Oh, yeah. That works.
Oh wow, something burning.
Oh God, no, it's David Flash.
Oh no.
Why would you do that?
Man, can dream.
Yeah, wow. I have this PM 2.5 filter in my mask, and even though it's just an insertable filter, it's actually working pretty good to block the smoke from my lungs. So that's cool. This is an adequate picture. Can I turn the brightness all the way up? Oh, there it is. Well, let's see if this works. Wait, yeah. There's the moon on my not so great phone camera.
I think they can still see it.
Yeah. Well, everything looks kind of red right now, but
yeah,
I promise the moon looks really cool. If you, I guess you could just go outside and look at it on your own.
Yeah, the red light doesn't. Oh,
Yeah. Plus, I probably have my red screen filter on since it's nighttime.
it is smart though. I can convince myself that this is some kind of feature. In my mind, I'm seeing a feature right there.
Yeah.
Oh my god. And maybe.
Well, I'm having fun. I'm definitely gonna come back on a clear night.
Yeah.
Yeah, if I can just, as I was saying to Marcel earlier, know that it's a pandemic and I don't have a life or, anywhere to go, I guess I could just come down to SBO on every Friday night and just like really finally become like the amateur astronomer of my dreams and actually know where things are, like, boom, other than just the big couple constellations that I know. That would be super fun.
Eventually, we'll try to get there.
Are those two stars named the same thing?
Which ones?
Masim and Masim.
I'm pretty
Maybe
sure.
there's just the same label.
Yeah, I
One
think
star.
as I go closer and closer. Aha, there. One can dream.
Yeah.
No, it's not going to be visible.
Yeah. I mean, we can just point out random objects and people
Yeah.
can Wikipedia them if they want or Google them.
Yeah.
Yeah, so this M13 is a favorite object for star parties that we have selected right here. Oh yeah, we can also just bring it up on the screen because it's like, well, it's only a camera that we have anyway, so we might as well just bring it up. Yeah, so bring up that M13. So this is one of my favorite objects. I saw this for the first time without knowing what it was at a star party in Eugene, Oregon. And here is a very nice picture, sort of, without a lot of context because it's taken from up in space from what the Hubble Space Telescope. Yeah. Yeah. But this is a really nice object to look at in the telescope because with, the right size telescope, probably somewhere between like a 6 or 10-inch Dobsonian or something like that, and it's like that biggish. You'll see just a really beautiful, like you'll see this is like what you see through the telescope. Thank you. So just this beautiful black space, with stars everywhere, and then it just looks, I can't even describe to you what this is like in the telescope. You look at this and you see it in the telescope and you're like, that looks unreal. Like I've seen that on the internet, but this is a real thing that I'm looking at in space, and that's just wild to me.
Nothing that makes me happier than a bunch of stars
Yeah.
together.
Yeah, so this is a really nice example of a globular cluster. Again, this is M13, the Great Cluster in Hercules. So this is a bunch of very old stars that are gravitationally bound, which is why they look spherical like that. And it lives in the halo of the Milky Way. So the Milky Way is like this big old spirally disk, but there's like sort of, if you put the disk like in the plane like this, then there's like a halo on top of it that sort of forms it into a roughly spherical shape, but most of the mass is in that disk. But then you'll have some sort of in a dome on either side of the disk, and that's the halo, and this is where these sorts of clusters live. They're very, very old, extraordinarily old. Like, don't ask them how old they are old.
I don't like to get that question.
We've dropped to one person. I think we're just talking to ourselves and Seth here.
Hey, that's something though. What else do we want to point out? Not see anything. Messier what?
I like the wild duck cluster. And I don't know if it's that M11 down there. There's also, what are the other ones that are up right now? I wrote some down. M52, M15.
15? 52. Let's start with 15. Messier 15.
Useful book.
Oh yeah. When you mentioned that, I was like, what is she talking about? And then I Googled it and I was like, oh my God, I need this.
Yeah, but this is like a weird version where the binding is like this, but you can get a copy where get a copy where the spiral is
Yeah.
like not enclosed
Outside.
by that, so you can actually do this without breaking your book.
Probably safe. Okay.
I wonder if there's any podcasts where like astronomers just look at stuff. That'd be kind of cool.
I think I saw one today. One of the links that I sent to you. I was like, "Oh, observation podcast," and I was
Oh,
like,
cool,
"Is this a real thing?"
I actually didn't click on all of them because
That's fine. I just
yeah.
like was randomly googling stuff, and I saw that the CU department has a bunch of links for like observation. I was like, "Oh, I'll send those out."
Yeah. Let's see. Here's our charts. So these are the charts that I like to use. So we got M52, M15, M2. Those are, so M15 and M2 are all globular clusters as well.
So right now we're trying to look at M15, but not being successful here.
Yeah, that's going to be washed out in the noise.
Yeah.
So normally we can see objects down to about 6th or 7th magnitude at best. I don't know who's watching right now, but if you're not familiar with magnitudes, it's sort of this like ridiculous system because it was created back like in, like hundreds or thousands of years, like BC, like whenever the Greeks were doing stuff and looking at stars.
Yep.
Sorry, I'm not a historian. I haven't taken history since high school.
You're probably
hundreds of years.
Yeah.
Probably not thousands of years, maybe just hundreds of years. But yeah, so they had to base everything on what they could see with their naked eye, and sort of calibrate it to whatever the brightest object in the sky was. But then later, when technology was invented, we were able to see a lot fainter things. So the scale had to be adjusted to account for that. And it's also it's a logarithmic scale because our eyes and our ears are actually logarithmic sensors, and what that means is that and I'm probably going to butcher this, but they're sensitive to like orders of magnitude of differences. So like if you think about like the decibel scale for sound, it's not just like, if you add 1 decibel, it's just going up sort of step by step. It's that when you go up in a decibel, it's like, I don't actually know what it is because I don't know decibels that well, but like every step in magnitude is, what is it, like 10 to the 5.5 or something like that.
It's
some weird number like that. So it's some multiple
fraction, yeah.
Yeah, so it's not just like +1 +1 +1. It's like multiple. It's multiplied. So you can look at a bright object like Vega, like we were looking at earlier, and Vega is actually a magnitude of 0. It's basically the object that everything else is calibrated against. It's just defined to be 0. And then really bright objects like planets, or, well, actually, maybe I shouldn't say that because I'm not totally sure that the planets are this value, but really bright objects have a negative value for magnitude, which is sort of counterintuitive.
Wow.
And the sun is like a very high negative number because it's very bright. Whereas the larger the number is and the more positive, if you have positive numbers, the larger they are, the dimmer the object is. So like 5th or 6th magnitude will get us some relatively bright deep sky objects like galaxy clusters, like galaxies. Not whole galaxy clusters. Oh my goodness. Just one galaxy at a time. Yeah.
Our field of view is not that big.
Not that good. But then like as you go dimmer and dimmer, like earlier one of our viewers asked about looking at asteroids. Asteroids are somewhere in like the tens of magnitude. So I don't know, like 15 to 20 or something. They're very, very dim. Some I think are even, I think if you heard about the interstellar visitor we had a little while back, which was some sort of rocky object. I think that was down above 20, but very, very dim, as I recall.
I wish I could pick up what this is because we're looking at that. There's like one very bright object
In M15
52.
or 13, M52.
Yeah, but
Well,
it's
let's see what I have.
it's like bottom left, bottom right. Sorry.
This probably won't actually have the information because it's just showing them as points.
Yeah.
Did you look it up online?
Oops. about that time.
One very bright object in M52.
Yes. BMW M52. That's not what we're looking for. On cars.
Oh, yeah, there it is. I see it right there in the picture.
Right, yeah. It's probably whatever this is.
Yeah. All right, so is it going to give us like a little guide of what we're looking at here?
Let's see. Let's
Nope. There might be like a star if you go out to the main article. There might be a star. Nope, never mind. There's
It's
nothing.
not very big. But I think, okay, so it's this thing.
Yeah.
Very bright. And I was looking at the picture and
Actually, it might not be that thing
yeah.
because the orientation might be weird.
Exactly. Which
Yeah.
is, yeah. I was looking at this one because it should be like, live orientation, but it's not intuitive to like
Oh,
there's,
yeah.
there's a bunch of like bright stuff here. I thought it was this one because it's like very, very bright and it's kind of
Yeah.
like towards the side.
Yeah. That's going to be tough to pick out
Yep.
without more things to look at.
Probably some homework,
Is the chat scrolling?
No, I think our one incorrect viewer doesn't
Alright.
want to talk to us that much.
That's okay. That's fine. We are here for your entertainment.
Yep.
All right, what else is good to look at? So what does this thing look like in the Wikipedia picture? Is
Yeah,
the same as
let's
that?
go.
And my mask won't stay up.
It's kind of better because it doesn't have that circular like I don't know, kind of like snapshot.
Yeah, so this is a, what is this? Is this a globular cluster?
I want to say
Open cluster. That makes more sense. Okay. Yeah. So the open cluster is similar to globular cluster, but it's much younger stars living in the disk of the Milky Way, and not as tightly bound as the globular clusters. This one looks like it has a bunch of gas and dust obscuring parts of it as well, which is what that deep inky black is.
yeah.
Various parts. I need to just like have this all in my head. I mean, I have quite a few things, but not a whole lot of things. These I just looked up before I came here. How about Aydah Cassiopeia? This is a double star.
You type that in.
Oh, I don't know how to type it in without Greek letters. Yeah, okay, we just spell it out. Aydah. I don't think it's going to work, but I'll just look up Cassiopeia. Yeah, Cassiopeia. Cassiopeia is salt and pepper.
No.
What am I looking at here? Yeah, there she is. Okay, so wait, where's Cassiopeia? Hold on. It's one of the stars in Cassiopeia. And it's a
Okay,
double star.
so
Where she is? Yeah, okay. Aydah Cassiopeia between Alpha and Gamma. So if I actually scroll out a bit, find the brightest star in Cassiopeia. It's
So-
it's that.
is it this one?
Wait,
Or
I'm confused
Navi?
by this orientation.
Yeah. It's not really making it any better. Oh no.
No, it's actually harder to see now.
Yeah.
What are the names of these darn stars? Oh, Cassiopeia C chart 19. So this is the shape, but I just don't see the familiar shape.
I don't think that's the same thing we're looking at because this thing is. Okay, no.
No, it
I
is.
think
M34 is right here.
then, yeah, it is. Like this.
Oh, now I see it. Okay.
Yeah.
There's just some extra stuff in there.
Oh yeah. So
Okay, so Aydah Cassiopeia is this one right here, this acrid.
Okay,
Acrid. So this is supposedly a double star.
Center there.
Oh, but in this program, I guess it could be any of the stars. Oh, yeah, now it's showing 2 because it's a double star. I see. I wonder how far it would go. This may not be interesting to look at on the program, but
We can Google it.
yeah, it's nice to look at the double stars in the scopes. Especially during the summer when there's
What was the name of the star again?
Achrid, A-C-H.
AC. Astrid.
Oh wait, without the T, I think.
Oh, jeez.
Okay, so this is apparently a drug, but what we wanted was the star.
Let's see. Astrid.
Yeah, I'll put star next to it.
Yeah.
Yeah,
Oh.
Aydah Cassiopeia. Binary system. Is there a nice photo of it?
So there's something.
Oh,
Like a simulation of it.
sick.
That's cool. Look at those orbits. It's kind of
Wow,
cool.
is that really their orbit? That's mad.
If it is, it's amazing. They're like orbiting each other and have such a.
This is probably like super sped up, but yeah.
Oh yeah.
Well, thanks
Just like
Lopez
vroom.
Pablo 87 who made the simulation. Yeah, so in the summer here, which is mostly when I come,
I think you can almost.
yeah, we do we'll do like Alberio, which is in the constellation Cygnus, the eyes of the swan, or is it the tail of the swan? Well, it's one end of the swan. Either way, I think it's the eyes, which is a very nice like orange and blue double star. And then a lesser known one is actually one of the stars in the Big Dipper, the handle of the Big Dipper. And I can't remember exactly the name of it. I think it's like Murphak and something else.
I'm surprised you can even like name that.
Just doing it for a lot of years.
Yeah.
Here in Boulder, you can only see certain things, like I said, like down to 5th or 6th magnitude. So it's kind of, we look at similar things on every open house night because we can't look at everything in the sky since it's too dim. But yeah, that's a good one. You can actually see that one with your plain eyes on a really clear night. Oh, is that Alberio? Oh no, that's Aydah Cassiopeia.
Yeah.
That's nice.
I just found a better picture. I was like,
sick. What time is it?
it's actually 9 o'clock already. So
Are we supposed to stop at 9?
yeah, this is about the time where.
We only go
stop.
for an hour?
Yeah.
Oh, okay. Well,
Any other time you guys like extra? If people are hanging out,
Yeah.
usually know when they're.
well, but we only have one on here, and I'm still not convinced that this one person is not just Seth. So it might be time for us to wrap up here, especially since the clouds have just not improved. Actually, the moon is up now. We might be able to look at the moon finally.
Yeah. Yeah, I bet you can actually look at it right now. And maybe you might actually be able to see Mercury because it's actually visible.
See what? Mercury?
Yeah, it's visible with the naked eye. So
Really?
yeah, you could either that or I'm just crazy.
Whoa. There we go. Okay.
Oh, someone's calling.
Okay. I'll look for the moon.
Hello. Well, I don't know if that's the name.
What's
Oh,
that?
but we're doing the like open house observation, like YouTube stream. So if that's what you mean, then yes. Yeah, right now it's only on YouTube. Right now the observatory is not open for the public. Yeah. Okay, that's fine. Thank you.
She just wanted to know if she could come down.
Yeah. Yeah. Be like, no.
Tragic. Yeah.
Dark sky.
Okay.
That should be the name of this thing.
Is there a way to like reorient this? Because I think it got messed up.
I think, yeah. So,
Orient to the terrestrial sphere.
okay, yeah. That makes
Oh.
more sense.
No, I don't like this anymore.
But you can just change your orientation to
Celestial sphere.
Yeah.
That's not what I like either. Wait, where? Oh no, this is right. Yeah, this is good. Okay. So we're trying to look at the moon, and it's just on the edge.
Oh, Mercury's there though.
Mars?
Mercury, Mars. Yeah, Jesus.
Okay, I was really confused. I was
No,
like,
no, no, no,
that
no.
doesn't seem right. Whatever.
No. I don't. My brain. I need sleep. Sorry.
It's okay.
That's Mars.
Okay, let's look at Mars. Actually, it might be a little close. Maybe we shouldn't do it. It's a little close. Ooh, look at that. No. No, you get too close to the edge, the telescope crashes, and Fabio gets mad, so we don't want to do that.
Yeah. No, I was kidding. But I mean, if I wonder how much time we could wait to see it.
We can wait like 10 minutes
Yeah.
or something.
That's fine. I'm gonna put this. Right.
Oh yeah, you could. I mean, you could put it up if you want, but I think
Honestly,
we lost the story.
I don't think it's gonna improve our observations too much either. I think also this, like the roof, kind of messes it up as well.
Am I looking at a cloud going over the moon right now?
Oh yeah, I think so.
That's pretty cool.
I mean, if you have a camera that can take a picture like of an astronomical, if you have a good lens, like a zoom lens, it would be a great night to take a picture.
Oh yeah.
It looks kind of sick.
I should have brought my camera. It's not that good, but it's better than a phone.
Yeah, I have like a 200 like millimeters lens. It's decent
Nice.
enough that you can take a picture of the moon.
Yeah.
Of the moon.
Oh yeah, this is a very nice book. I like this book.
Did you buy it on Amazon?
I don't know. I bought it a long time ago. But I mean, yeah, you can buy it anywhere really. It has these nice charts, and they tell you like where they are during times of the year,
That's cool.
and they have this way they show you the seasons and like where the charts are, or, like which numbers to look at for which season.
Well,
And they give you a little checklist, like here are some common objects you can check off when you see them, and like what you think about it. It's pretty fun. The pictures are kind of old, some of these. Yeah, and then they give you like an overview of the objects, which I always need because I always forget what things are. I just had to crib before I came down here, just in case anyone asks me, how far away is this globular cluster?
like,
Well, it's about 50,000 light years, approximately. Oh, nice. Visibility of the planets 2006 to 2018. Well, it's out of date. I have to get a new copy. Where to find Mars specifically? Okay, they're all for the different planets. Fair enough.
You should know.
Sure. I don't know where Mars is.
Near the moon. That's about it.
Astronomy from the city. Give up. No, I'm kidding.
Get away from the sea. That's the first paragraph.
There's some very nice places to get out of the city here.
Oh yeah.
Oh, these ones are good too. These like sort of just what the sphere looks like.
Yeah, and actually with the map, well, it's kind of sick.
Yeah, and so this is to give you a sense of what you're looking at when, because you're not looking for stick figures in the sky. Okay, it says the moon. I don't think it's quite ready yet. I think this orange line is a lie. I think we should wait a little bit more. Let's see. Mars might be doable.
Yeah.
Don't crash, don't crash, don't crash.
Doing it.
It's not quite there. Okay,
Okay.
that's good.
I think the exposure is probably very, very high.
Yeah.
Oh. So, camera.
Oh, it's actually low.
That's what I meant, sorry. Probably. What are you doing? 0.5 for
Yeah. That works for Jupiter.
I would imagine it'll work. Quick filter over here.
Mars and the ultraviolet.
Let's see, I'm working for Jupiter, so whatever.
There you go.
What's that over there? You have a little friend?
It could be Phobos.
Oh my god.
It could be Phobos. It could be some plume of H or whatever. Oxygen. I don't know. What would give off light from the ultraviolet?
But
Not H. It wouldn't be H.
no, ultraviolet.
Well, actually, it could be H. I'm full of lies. They all have emission lines in the ultraviolet.
Because it's just like
Honestly, it's probably some star that's intervening. It's probably not anything planetary.
maybe this over here.
It's too far away. It's quite close.
Yeah.
Should take it with another filter. See what we get.
Red.
There you go. It's red.
At least this one's visible. I'm gonna do this.
Neat. Circle.
Come on, you can be a circle if you believe enough.
This is a really bad distribution.
Oh yeah. Basically, I'm singling out one pixel
Yeah.
of you. Either you're the maximum or you're the maximum.
What was the one that showed the like streaks out to the side?
Probably here it's a little better too.
I wonder if that's actually, if we're looking at the corona or anything, or if that's just a bunch of nonsense. It's probably nonsense, but I should
So
really
when-
know the
so
answer
when
to
you
this
refer to
question.
the
I really hope
corona-
my advisors know on this call.
The corona.
Yeah.
What are you?
There's like an extended envelope of hot hydrogen that's just hanging around the planet,
Okay.
and we call it the H corona. There should be some O corona as well.
You know what? It's a great thing.
Hot O.
O3.
Was O3?
I think it's O3.
Okay, we'll give it a shot.
I don't know what it is. Specific. I think this is a thing they used to call nebullium or something like that. Did I take the picture?
I'm not sure. I don't think so.
I don't think so either, because they kind of look like the same thing. That makes sense. It's likely. Okay. I don't expect anything at all. Oh, look at that.
Huh. Interesting. I got some feature there. That's pretty cool. That looks like a 3D object.
Yes.
Wait, so does it say what the wavelengths are?
No,
No.
for that one it doesn't say. No, it's like wavelength. I think we can actually.
Yeah.
All three. I think it's this thing.
I think it's this. Yeah, filter. Oh god. Keyboard's not very easy to use.
I actually want a description.
You could do that useful filters. That should describe it. Prairie Astronomy Club.
Okay.
Oh. Yeah, I got this.
The,
Oh, oxygen 3 lines.
yeah.
Okay.
And I think
4959 angstroms, so 495 nanometers, so somewhere in the green.
yeah, I think here's this idea, line nebula filters. They see this
Yeah.
green stuff on the nebula, and they thought it was like a different like element.
Oh,
And
okay.
we talked about this, and they used to call it Nebuldium or something like that.
Oh, okay.
And
Oh,
they,
so here we're looking at this very narrow band oxygen emission from Mars. I'll go back to the photo.
Yep.
So this is not the hot oxygen. This should be the relatively.
I think this is a forbidden line. Yeah.
I don't think it's very hot. If it was a lot hotter, we would see it further out from the planet. Although there is sort of a bit of a halo, and actually, wait, oh man, no, go back to the like
Yeah,
the good one.
Yeah, I wanted to go this one because I messed it up, and I was like, oh no, what did I do?
Yee.
I know I like touch it a little bit. Okay, like I think that's fine.
Yeah, so this looks like a little bit of maybe a feature to me. This I would be really interested to see what if we could somehow overlay the magnetic field, because it looks like there's more emission right here, which would indicate that would be the magnetotail.
Oh, that'd be sick.
But I'm not sure, and I am not a magnetospheric or ion person, but that's based on the little I know.
Yeah.
That's cool. Not the brightest lines of oxygen for Mars, but a line that I did not previously know about.
Oh, no.
One of the brighter ones is like at 130 nanometers.
That's cool.
Yeah.
I wonder if the moon.
I remember that for sure. The moon should probably be out now. But it doesn't have an atmosphere that's escaping, so it's boring.
Come on. Fine.
Moon Pia.
Ah, yes. You know.
All right, let's see where we're at. It zoomed all the way in.
Yes.
That's great. Yeah.
Okay, so are we?
Yeah, I think we're good. I think it'll get it. It's gonna go like slightly downward. Very,
You
very
hear
slightly.
that?
Yeah.
Like,
Okay.
whoop.
All right, take a pick.
Okay, we probably want to change this thing though.
Yeah. Can you just set it to like the general whatever?
Green?
Can we just do no filter?
I don't think it has an option.
Okay, so we have to pick one of them.
It-
I guess green is reasonable, yeah.
Yeah. Okay, perfect. Camera.
No, that's gonna be super bright.
Oh no, sorry.
Yeah, let's do it like 0.1 or something.
Keep forgetting it's so close.
We gotta go even shorter.
Do you want to jump to the?
And just do what? Try 100th of a second. All right, less. Try 1,000th of a second. Damn. Oh no, I swore on the live stream.
Let's go crazy.
Well, that's gonna saturate it.
Yeah.
Can we do less than
No,
this
this
much?
is the lowest we can
Okay,
go.
we're not gonna be able to take a picture of the moon. Oh well.
Actually, maybe if we go into one of the other filters, like one that has such a low emission.
Yeah,
I wonder which one though.
H alpha would be hella low.
Yeah, but
I don't think you're gonna get anything.
anything exactly. That's what I was thinking. Like,
Shouldn't get any oxygen either.
yeah, maybe.
If you're in your H alpha, I think increase the exposure.
Here.
Oh, not what I expected.
Also.
Oh, there we go.
Yeah, it's just. I don't think it's an issue of. We're
That's
just
pretty
too
cool.
close to it, so
Yeah.
our field of view just.
Well,
sees
it's
this.
probably a little of both.
Yeah, because like, see, like we're getting some sick
Yeah.
features here though.
Good shot of whatever Mare that is.
So I think we can actually can we move all the way over here? I don't think so.
There's something visible right above the moon. It might just be Mars, though. It might just be like weird orientation.
Yeah,
Yeah, it's just Mars.
yeah, Mars is over here.
Oh yeah, because that's the horizon. Okay.
Yeah.
Neat. Well, I'm satisfied.
Yeah.
We could all go home now.
Yeah. For our one viewer.
Who I think is probably not actually at the computer.
Yep.
Or just very entertained by two very boring grad students.
Hey, look at us. Well, thank you very much for joining us. If you are there, if you're not,
Or if you
fine.
watch this later.
Yep. Have a good night.
Yeah, we'll be back in what, 2 weeks?
2 weeks probably, maybe less,
All
maybe more.
Cool. Good night.
Find
everyone.
out next time on
SBO.
SBO.
All right.
Subscribe.
Like and subscribe.
And,
And the meeting.